Hello everyone, I am Xiao Gang. Okay, in this lesson, we will continue looking at sorting. For this sort, first, we'll look at its own sort function, and then discuss the binary position method. Then you see these numbers undergoing a simple sort. Its sorting method is case-insensitive word point programming comparison. Okay, that's what it means. Next, let's implement the sort function first, and then we will... This will be discussed later. I have already implemented it here, but first I will delete all the previous code. I won't delete the same flow. So here we instantiated a sort array like this, a function of the sort array like this. Then we put it into this region. And then we create its implementation. Note this spot, because it seems the creation method still cannot automatically properly apply this region, so we will manually do it here. First, we still need to declare a host for the position, but we won't use its host anymore for easier management. Let's look at the poetry of this sentence. It is according to this operator. Perform a case-insensitive dictionary compilation, sort and table. Then let's explain it. Let's write the host like this. We write A like this. A, and then we write another one. A, B, A, B, A, B, C, B, 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 E. B, E, V, E. We can just write whatever we want next. Then C, 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 C. Let's look at this place and see why there is a red line. It should be here. Take a look. Because it's in this spot. This area is easy to get confused by. There's an extra one here. Let's give it a longer one. D, 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 A. Okay, we want a host like this. Otherwise, to make it more intuitive, we will change the order of these host elements. Let's run a simple test on it. We'll just place it here for now. Okay, then we'll have it perform this sort. Now let's take a look at the result. Because if you sort it this way now, it should be the same. You might not understand this. Let's run it first. We are here. We call this method here. Similarly, it's still begin play. We execute it, and then it is like this. Then we see what it looks like after the execution. You find that after processing, it arranges itself in this way. It follows this dictionary. It means it will first compare the first position. The first element, A, must be at the beginning. After A, we then compare the second position. After the second position is compared, then we compare if there is a third position. Here, we start comparing the third position. This is based on this dictionary. The meaning of this arrangement. We can click on it to take a look. Let's see if there are any comments. At this point, it's already at the H spot. Maybe there isn't a place here to check it out. Something about this area is incorrect. Do you see it? Here's an experiment. Proving that it is not in the H we want. Then our correct H should be here. And this lets us directly search for our sort. Here, this place is for sorting this host. And then our operator it has already been defined by this mate shape. If your host contains this native pointer, they will automatically take references. Therefore, your host should be sorted by the value that the pointer points to, and not by the value of the pointer itself if this place has not been deserved. If it is not required, we can just use this to perform a sort. And this automatically links the references. It will not happen in the smart indicator like place. Okay, so that's basically what it means. So actually, regarding the sorting, it performs a dictionary sort that ignores case. So we won't look at this first. Actually, you have two more functions here. One is TableSort, and one is StableSort. We can also call them in sequence here. So let's write it like this. Let's connect it. This is sort. Look at this. How is this character spelled? No, it's not misspelled. Okay, let's take another look. Okay, let's copy this down. And the way they sort these parts is just different. Okay, we won't elaborate on the specific sorting algorithm in detail, because talking about the algorithm would take a very long time, and what's more, this is quite frustrating when it comes to fundamentals, because we just need to look at these implementations within UE5. Okay, now let's execute them sequentially. Then we see if there are any duplicate objects here. It seems like there are no duplicate objects here. Let's add a duplicate object. Let's add an A. Add in A. Then here of course, we changed it here. We move it down here. Sort. We sort this area. Sort. For sorting. Sort. Stabilize the sort. Let's execute it again. This shouldn't be a problem. Okay, let's take a look at this. This is the result before we sorted it. We will check the results after sorting. You see A, B, B, A, B, C, A. We haven't sorted it yet. We need to execute one more step. You can see, right? Because this part is ignoring the capitalization. So these three things should look the same to him. Actually, this AB is the same as AB. Let's take another look at this stack. Okay. Do you see the spot? The results we get out are actually the same, right? Okay, let's take another look at this StableSort. You can see that it's different, right? Look at this A, it's at the very top. These two A's are at the end, because although it's called stable sorting, it just means that it assumes that these two values are the same. But they have a skew Kinnan order because this AA appears before this AA, right? See, this AB appears before this AB appears before this AB, then later we'll reverse it. let's take a look at the sorting we did before, what it looks like. Then let's take a look at what it looks like after sorting. You'll notice that A is on top. The order might be unstable. Because they are all the same, if we sort them according to dictionary order, you can take a look at this little a and little abb. Then we will directly jump again and let it execute again. Okay, you can see it's actually these two. The effect of the two is the same, but the stable sorting is different if they are the same type. It will have an order of appearance. So let's take another look at this. It's attention on this place. We cannot do this until it is binary. So it basically means that this step slot, it can be used to guarantee the relative order of the sorted, relative order of equal valued elements, and this heap slot and this queue slot, they are actually unstable. The relative order of equal elements cannot be guaranteed. And specifically, the difference between a heap slot and a slot is about the difference in sorting efficiency for specific data. It's about implementing a sort using different algorithms. Because there are many types of sorting algorithms, you can look this up here. Right? Sorting, quicksort. Actually, the official documentation for this place corresponds to it. It actually corresponds to these 3, 5, 6, and 7. This can also be used as a quicksort implementation. As an implementation for this quick sort, this is obviously just stacking. Then let's talk about this binary relationship. Binary relationship means that, like this establishes a relationship between two objects and returns a Boolean value. So it is called a binary relationship, and this type of syntax, it passes a function into it. It's through this function to compare the size of these two elements. We call this a lambda. We call it a lambda function. So in this place, we pass the function value. Then, actually, this thing is quite common for us because we will often use things like function pointers, and sometimes it's good for everyone to learn and adapt to this such a large scale. Then we will proceed to implement this. It's comparison method. This is what we are comparing. Before we implement this, let us show you all this. Take a look at this. Operatives. How do we search for this? Let's enter this, enter a string, then we click into it. Then we look and check the position, see if the position is correct. Then there are no problems inside the call. To prove that it is what we want, then we enter operated in that location, because we know it overloaded this operation service. Okay, we should be like this. We found it. This is comparing this. Dictionary sort. You can search for this word. What does it mean? Actually, perform a simple sort based on the dictionary order. Then it calls this planet for stream. Planet 4 is a very special prefix. Why is it special? It is a cross-platform intermediate layer. We will do this before calling a specific platform. It will call this platform, that is, it controls through red. If this version is Windows, then I use the implementation of this string on Windows. If it's Android, then I use the implementation of this string on Android. You can see this. When we enter, it's Windows. Actually, it is used in many places. This Apple, this Unix, Windows, Android. You can find that they have quite different definitions and implementations. You can see, and this is not simply, it's in a string. Actually, at this point, we collect this. We often do ready-made related work. We will also do this here. Pockets, right? Memorize, isn't it? Is it like this? Message is some miscellaneous items. Possibly get the unique ID of these devices. Hardware ID time. So, we learn UE5. You already know C+++. Or you. Then, why do you still need to learn UE5, C++? It's because of the cross-platform aspects of UE5 that you want to learn this way. Okay, we'll discuss that in the next lesson. Binary position, we will implement it first. Then we will use our own struct. Then we will let everyone practice it in a real-world scenario. Generally, things like this. How it is used. Thank you all.